Today we're going to take a look at the second portion of triangle congruence. So you have already looked at the 5 triangle congruence postulates: side, 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 angle, side, angle, side, and hypotenuse leg, which has to have a right angle. Each of these postulates requires you to know 3 pieces of corresponding congruent sides or angles. You cannot prove triangle congruence without 3 pieces of matching information in each of your triangles. But it is also very important for you to understand that you cannot assume any information to be true. Just because triangles look the same on the piece of paper or the computer screen does not mean that they're actually congruent. They have to be marked as congruent. So you have to have all 3 sides marked. You have to have 2 sides and the included angle mark, and so on. Everything has to be marked. You cannot assume anything at all to be true. Now, when we look at these 5 triangle congruence postulates, I have them listed over there on the right-hand side with those markings. So side, 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 you have to have tick marks on all 3 sides of each triangle. Side, angle, side, you have to have 2 sides and the included angle marked on each triangle. Angle, side, angle, you have to have 2 angles and the included side marked on each triangle. Angle, angle, side, you have to have 2 angles and the non-included side marked on each triangle. Hypotenuse leg, you have to have the right angle marked, the hypotenuse on each triangle, and a leg on each triangle. Now, if the triangles are not touching, like those are in the pictures on the right-hand side, there is absolutely nothing else that we know to be true. We can only go with what is marked. However, if the triangles are touching, it is possible we might know a little bit more about how those 2 triangles relate to one another. If they are touching in such a way that they make a pair of vertical angles. So let's remind ourselves, vertical angles are formed when 2 straight lines intersect. The vertical angles are the ones that are opposite each other. So in this diagram, A and B, the ones with 1 tick mark on them, those are vertical. They make a pair. And then C and D, the ones with 2 tick marks, those make a pair of vertical angles. So when vertical angles happen, you have 2 pairs. Only 2 of them would be in your triangle. So if you look at the diagram then on the lower right, we have 2 triangles, LMN and PNO. And the angles at N are your vertical angles. But let me see if I can get my cursor over here. It would be this angle that is at LNM right here, and then its partner straight across of PNO right here. That would be congruent to one another, and then we would be able to utilize those to prove triangle congruence. So let's take a look at these. Here we would look at determining if these triangles are congruent. The one on the left, we have triangle ABC and triangle CDE. They're touching at point C, which is a place where 2 straight lines intersect. So these are vertical angles. So angle ACB and angle ECD are going to be congruent because they are vertical angles. Remember, when you name an angle, you have to use all 3 letters since there's more than one angle at that location. So after we would make a tick mark here and a tick mark here showing our vertical angles, then we would have side, angle, side, side, angle, side. So those 2 triangles are congruent by side, angle, side postulate. In the diagram on the right, we have 2 straight lines intersecting at point K. So we have a pair of vertical angles here at K. We would have JKN and MKL, these 2 right here. So we would mark those as congruent. And after we did that, we would have an angle, and the non-included side, an angle, and the non-included side. So the angle, angle, side postulate is how we would know those triangles are congruent. Now, triangles don't have to touch at a point. They can share an entire side. So here we have 2 triangles. They're intersecting here, and then we have the vertical angles marked kind of with a purplish color right there. These 2 would be touching at a point. This sort of more butterfly looking one would also have a pair of vertical angles here. One of them is marked, the other one is not. But those are also touching at a point. But in these two diagrams down here, we have an entire side that is a part of this bottom left triangle and the upper right triangle. Here, XZ is a shared side. It belongs to the triangle on the left as well as the triangle on the right. Those are going to be something we're going to use a property called the reflexive property with. In geometry, the reflexive property of congruence states that an angle, a line segment, or anything that has to do with a shape is always going to be congruent to itself, which just sort of makes sense. So if you say like angle A is congruent to angle A, or segment AB is congruent to segment AB, or shape O is congruent to shape O, whatever it is, it's always going to be congruent to itself. So in that realm of thought, if we look at triangles that share a side, like this one over here, AK belongs to the triangle on the top as well as to the triangle on the bottom. And because it is always congruent to itself, then AK is congruent to AK by the reflexive property. Let's use that. So here we have two triangles, one on the left, one on the right. They share this side RS. So RS is congruent to RS by the reflexive property. Things are always congruent to themselves. So we'd make a little tick mark on that. Now in the triangle on the left, we have an angle, and a side. And in the triangle on the right, an angle, and a side. So these would be congruent by the angle, side postulate. In the example on the right, we have a triangle on the top and a triangle on the bottom. CA is a side that they share. CA will be congruent to itself. So we'd put 3 little tick marks on there to show it's congruent to itself. And at that point, we would have a side, and a side, a side, and a side. So these two triangles are congruent by the side, side postulate. So you cannot assume any information to be true, but you can know information that's true if you see vertical angles, because we know vertical angles are congruent, or if you see the reflexive property, because we know that a shared side will be congruent to itself. Keep in mind, though, not every triangle that touches the other triangle will have vertical angles or reflexive property. There's 3 examples down here. They're touching, but these are not vertical angles. Remember, vertical angles have to be 2 straight lines. This is a line on the bottom, a line here, and a line here. That's 3 angles or 3 lines coming together, not 2. These have a shared side only in that little portion right there where they touch, but that's not reflexive property to go all the way down to the corner. And then this is another one where we have a flat line on the bottom and 2 more lines. That's 3 lines intersecting. That's not vertical angles. So the only additional things you can mark are vertical angles and reflexive property. You can't mark anything else. Don't ever assume something to be true. Make sure you're only going with exactly what you know.